Hello everyone. I'm going to do another example of the least squares regression equation to help some of you folks out who are still struggling with either execution or completion. I'm going to use an example of calories and calories from fat. This comes from a data set that we've done with nutritional info from different restaurants previously. I'm just using this as a demo. I don't know if there is some sort of a relationship between calories and calories from fat. I will assume that there probably is. I will assume there's probably a positive correlation there. But then again, I don't know if what we find will be explaining that calories cause us to have calories from fat. So don't get carried away with that. What I want to do is take you through. If you need a companion in terms of the formulas, turn to page 157 and 158 in your textbook, and you can follow along with the equations there. I'm not going to show the equations. I will show you what I'm doing in Excel. I will show you what I'm going to be doing on Microsoft Mathematics. The rest is going to be on you to either replicate it or do something similar to see if it's working. Okay. Quite simply, I want to get a scatter plot of my data. So again, this is a pretty complicated, no sarcasm intended there, but this is not a very complicated process. Here is my scatter plot. Very, very simple, very, very precise, looks good. Okay. We can put the line of best fit. It looks like we have a pretty strong positive correlation. Okay, so when we think about our R value, we're probably going to have a fairly strong correlation. Looks like we'll have a couple outliers. I'm going to choose my equation, or the format with the equation, and you can see what our equation should be. The rest of this is matching this up and making sure this works for you. So if you notice, I have the columns for x squared and x times y. Remember to do this, we'll just type in an equal sign to let Excel know we want to do a mathematical operation. I'm going to grab my A2 value, which is my x value, caret and square it. For my x times y values, I'm again going to type in equal sign for a mathematical operation. I'm going to take my A2, shift 8 for the time sign, and B2. If I hit return, it gives me another large number that doesn't make a whole lot of sense to us, but I'm going to grab them both. I'm going to drag bottom right hand corner. Voila. Next thing, or the first step in terms of writing this equation is, remember, we need to find the sums. So I'm just going to hit the auto sum button in the top right. I'm going to get the sum of my column. I'm going to hit enter. This is a cool little trick. I'm just going to, instead of doing it for all three, I'm going to grab the right hand corner, drag it across, and I had my three sums. I'm going to go ahead and highlight those. So we have the sum of the x, sum of the y, sum of the x squared, sum of the x times y. Might be a good idea to pause the video and write that down now. Once you have these values recorded, it's time to move on. The first step really is to find our x bar and our y bar, the average of the x values, the average calories, and the average calories from fat for our y's. So again, we can use a simple equals average. Now, some people might select the whole column and read the values that we get in the bottom, but you have to be careful because this includes your totals. You don't want to have a sandwich or anything that's 8,770 calories, or maybe you do, but that's kind of disgusting. So I'm going to choose A2, which was my first value, down to A20. Here is my x bar value. Now remember, we'll use these when we write our equation. My y bar value is going to come from the average of my B column. And again, I'll highlight these just to let you know that these are the values that we need. The rest of this monster, guys, I'm pretty much going to be doing on my Microsoft Math Calculator. Again, you really, really need this to make this happen. So from here, the first thing, remember, after we find our x bar, y bar, is to find, or the next step is to find our slope, our B value. And remember, that's that big nasty formula. A lot of you said was really ugly. But ultimately, we're going to take the size of our sample, which in this case is I believe, 20. And again, if you're not sure, just double check it. I actually only have 19 sandwiches here. If you look at the count here, I got 19. So I stand corrected. So I have a sample of 19 times the sum of the x times y column, or the x times y value, which is the 202.8100. And you get a big nasty number there. The second part of that numerator is the sum of the x times y's. So I'm going to take my 8,770 times 3920. Remember, those values came from the sum of my x's and the sum of my y's. I get another big nasty number there. Okay, so far so good. Now to get the rest of my numerator, again, the nice thing about Microsoft Math is I'm just going to click and drag the values I want. I don't have to worry about rounding values. I don't need to worry about any of that. Just let the values go, round at the end. So I'm going to find the difference. My numerator is going to be this, looks like 4,155,500, which again means really nothing to us, all right, at this point. The denominator, remember, is to take the sample size again, the 19, times the sum of the x squared column. Now remember, this is the one where you have to be careful. This is the x squared, so 444,3500. And from that, we're going to find the sum of the squares, or the sum of the x's, I'm sorry, 8770. Sorry, I lost track of what I was doing there for a second. And we're going to square it, which it's right here, a little nice button for you. And again, another big nasty number. And ultimately, I want to find the difference in those. So just subtract. Click and drag, enter. And again, get kind of a nasty looking number here. It doesn't make a whole lot of sense. But remember, when it's all said and done, what I really want is this value and this value, and I want to find the difference, so, or the quotient. So I'm going to divide this by what was in my denominator, and I get a decimal of 0.553, which matches up with what we have in our equation. Once you get here, so far so good, right? Absolutely. So we have our b value, we have our slope. We know that for what the slope represents is for every 0.55 calories, we're going to have 1 calorie from fat. Remember, that's the rate of change. That's important. That's a very important value to understand, and we need to do a good job of that. What the interpretations I'm going to be looking for on an exam. In terms of finding the a value, to find your y-intercept, remember, we're just going to say, well, a is equal to our y-bar value, which was a 206.3158, minus our b value, our slope, 0.5530637776831. You don't need that many of the decimals. I'm going to put them in just for effect. And we're going to multiply that times our x bar value, the 461.5789. And we get an output of negative 48.96 or negative 48.967, very, very close. And we just confirmed that's pretty much our equation. If you have further questions, please email me. Please let me know. If this video was helpful, please let me know that as well. Always good to know if what I'm doing is helping you. All right, thanks. Good luck.